So in this problem, we need to categorize the following measures as either scalar or vector quantities. Now let us begin. We'll start with the first one. So here we have 10 kilogram. That means we have mass here. We know by definition mass is a scalar quantity. So 10 kilogram is going to be a scalar. Then going to the next one, we have 10 meters northwest. Now 10 meters means we are discussing here about length. Now length is a scalar quantity. However, we also have an information regarding the direction. So here it's a 10 meters along the northwestern direction. So that means since we have a scalar length as well as a direction, this is going to be a vector quantity. So we have 10 meters in the northwest direction. Then in the third one, here we have 10 newtons. Now we know the newtons is a unit of force. And force is a vector quantity because force has a magnitude which is given by the 10 units in this particular example, and it has got a direction. The direction is not specified here, but of course, whenever we have force defined, the direction is an integral part of it. So 10 newtons is going to be a vector quantity. Next, we have 30 kilometers per hour. Now, 30 kilometers per hour, that means this is speed. Now, speed is a scalar quantity. It's telling us nothing about the direction. It's simply telling us that some object might be moving with a speed of 30 kilometers per hour. So it's simply a scalar quantity. Now the fifth one, we have 50 meters per second. Now 50 meters per second means again we have a speed, but this time there is a direction attached to it. That means this object is moving with a speed of 50 meters per second in the northern direction. So that means we have a vector quantity here. We're 50 meters per second towards the northern direction. Coming to the sixth one, we have 15 coulombs. Now coulombs, you need to know that coulombs is a SI unit of charge. Now charge does not have a direction. That's a scalar quantity. So we have 15 coulombs, which is a scalar quantity. Coming to the seventh one, we have 15 grams. Again, this is mass being a scalar quantity. So we'll put 15 grams in the category of scalars. Next, we have a weight of 20, this is kilograms, a weight of 20 kilograms. Now 20 kilograms, that's a mass, but there's another word that's being used here. It's not mass, it's actually a weight. Weight always has a direction. It's dependent on the gravitational acceleration. So that's why we're going to categorize it under vector. So we have 20 kilogram weight. It's a downward direction towards the center of the earth. Next, we have a degree measure of 45 degrees. So it's independent of the direction here. So it's simply going to be a scalar quantity. Number 10, we have 10 meters southeast. Again, 10 meters is a scalar quantity, but there is a direction of southeast attached to it. So it's going to be a vector quantity. So we have 10 meters in the southeast direction. Coming to the final one, 50 meters per second square. The meters per second square, that is the SI unit of acceleration. So that means here we have a quantity which is defining the acceleration of an object. Well, acceleration we know by definition is a vector quantity. However, there is nothing being mentioned here about the direction of this particular quantity. So we will be considering only its magnitude. So in the sense of a magnitude, we will put it under the category of a scalar. That means this is the magnitude. We have to be very specific here. This is the magnitude of acceleration that we are considering here. However, we have to be very careful if although the direction is not mentioned here, when the direction gets mentioned, we will be categorizing it as under a vector. So because of incomplete information, we are categorizing it under scalar quantities.